All right, in this lesson, we are going to introduce the idea of inverse functions. And so whenever you see the word inverse and you're thinking about a function, think of a function that undoes another function. Okay, and so some common examples would be if I had x squared where I was squaring a function, the inverse of that would be square root of x. And so we'll look at those a little bit later, but for right now, we're just going to look at linear functions or just general functions. And so when you're talking about a graph, you just switch the x and y. Your inputs become your outputs and your outputs become your inputs because that's what an undo function would do. And so in these examples, we have a table of x and y values. You literally just put all your y values in your x column. And then you put all your x values in your y column. And I like to do them all at once, entire columns at a time, just because it's easy to accidentally switch them as if you do one point at a time. So over here, all my x's are going to appear in the y column. I'm not switching any signs. I'm just rewriting them in the y column. And then the x's go here. So a common mistake is changing negatives to positives and vice versa. We didn't do any of that. We just swapped the columns. And so if we want to graph it, we just graph the new points by switching the columns. And so it says graph the relation and connect the points. And so if the original relation is graphed below, let's go ahead and label the points. We have 0, 2. We have 1, 5. We have 5, 6. And 8, 9. So I'm going to put these on the table. 0, 2, 1, 5, 5, 6, and 8, 9. Okay, so for the inverse relation, the y's are going to appear in the x column, and the x's are going to appear in the y column, and we're going to regraph them. So now we have 2, 0. Our y-intercept became an x-intercept. We have 5, 1. And I like to connect them as we go because with the inverse function, it's hard to tell what connects to what. 6, 5, and then 9, 8. Okay, and so if you have the graph, just flip the points, the x and y column, and then regraph it. And then now you have the inverse graph. Algebraically, we still switch the x and y. So if they're using function notation f of x, go ahead and replace that symbol with the y. So for example, we would write y equals x plus 3, y equals 2x minus 5, y equals 3x plus 7, and y equals negative 2x plus 6. It's the same thing, just notation. F of x is the exact same thing as y, but we want to have the y here, and you'll see why in a second. And so next, we're going to switch the x and y variables. And so x equals y plus 3, x equals 2y minus 5, x equals 3y plus 7, and x equals negative 2y plus 6. Okay, and then now we have to re-solve for the y variable. And so starting with this number 1, to solve for y, we would have to subtract 3 from both sides. And so we end up with y equals x minus 3. Over here, I'm going to go ahead and put the y on the left side. Over here, we're resolving for y, so we would need to add 5 first. Always get rid of the number that's not attached to your variable. And then we would divide everything by 2. Not just the x, not just the 5. The entire expression has to be divided by 5. And so y equals x plus 5 all over 2. Here we would subtract 7 first. as we solve for y. And then just like the last example, divide everything by 3. So y equals x minus 7 over 3. And then in this next example, subtract 6 first. And then divide the entire expression by -2. And so y equals x minus 6 over -2. And so there's a couple ways you could write this answer. It's not standard to keep a negative in the bottom of a fraction. So oftentimes we will pull it completely outside the fraction. And then if you want to put it on the top, that's okay. You would just have to either add parentheses around the top, or you would have to go ahead and distribute it to the top. Another way is sometimes we view this division by -2 as multiplication by -1/2. That would be another equivalent answer, still leaving the x minus 6. And so on a multiple choice test, just recognize that all of these are equivalent answers for the same thing. That way you don't think you missed it just because your answer is in a different form. Okay, and so the last step is replace the y with the inverse notation. So we started with f of x, and we are ending with f inverse of x. This notation, this little -1, means inverse. Okay, and so for my final answer, I would have f inverse of x equals x minus 3. F inverse of x equals x plus 5 over 2. Just like the other example, if you wanted, you could write this as 1/2 times x plus 5. You'll see why that's valuable later in the year. Over here, we have f inverse of x equals x minus 7 all over 3, or you could view that as 1/3 times x minus 7. Those are equivalent. You could even distribute the 1/3 if you wanted to. Okay, and so I'm going to do 5 and 6 starting from the top. So on the test, if they give you this function and ask you to find the inverse, your first step is to replace that f of x notation with a y so that x and y variable. And then now you need to re-isolate the y. So our first step here is to subtract 2. And then to get rid of this 5, we have to multiply by 5. The entire side, just like we divided the entire side, we have to multiply the entire side. You don't have to distribute it if you can. And so our final answer, using the inverse notation, f inverse of x equals 5 times x minus 2, or you could distribute it and write it as 5x minus 10. Both of these would be counted correct, and recognize that they are the same on a multiple choice test. All right, last one. First step, put y, and then switch your x and y. Now here, our first step is this entire expression is trapped by this 3. So we need to get rid of that 3 by multiplying. So now we have 3x equals the 2y plus 7. It's free because these 3's cancel. And then the 7 is not attached, so that's what we would get rid of next, leaving us with 3x minus 7 equals 2y. And then our last step is to divide the entire expression by 2. And so we end up with y equals 3x minus 7 all over 2. So our final answer, f inverse of x equals 3x minus 7 all over 2. If you want, you can write that as 1/2 times the 3x minus 7.